A breeding group of foxes is introduced to a protected area. After T years, the population of the foxes is given by the function below. Can you find a formula for the derivative that's pictured? Alright, so first of all, we'll use quotient rule for this. It's the derivative of the top times the bottom. Minus the derivative of the bottom times the top. And divide by the bottom squared. This part is going to become 0, but the negative will stay. And the derivative of the 1 is going to be 0. On top we'll have negative 2 times 3 to the negative t times the ln of 3, and then times a negative 1 times 2000 over 1 plus 2 times 3 to the negative t squared. Alright, so we're looking at these canceling, and we can combine 4,000 times 3 to the negative t times the ln of 3 over 1 plus 2 times 3 to the negative t squared. Okay, that's our first derivative. Next, can we use the fact that the inflection point of the logistic curve will occur at 1/2 the carrying capacity to find out exactly what time these foxes are growing at their most rapid rate? Alright, so from the graph, we see that the carrying capacity is 2,000. That's also in the formula. Okay, so we're going to want to find the inflection point at 1/2 the carrying capacity, which would be 1,000. So our inflection point happens somewhere right about here. That's going to be the time of greatest growth for the foxes. And it is also the time when the derivative is at its highest point. Alright, so finding a second derivative for this would be quite tricky, and then setting that equal to 0 could be tricky as well. An easier way to solve this would be just to let the population of these foxes be 1,000. And we could solve for the time that way. So much easier. Okay. So we'll multiply across. We'll get that. Let's divide both sides by 2 to get 3 to the negative t equals 1/2. Take the ln of both sides here. That's going to allow us to bring the t down. Because when the t comes down in front, we can now divide by ln3. And we'll get t equals negative ln 1/2 over ln3. All right, let's calculate that real quick. It's approximately at 0.631 years.